A gas station has a cylindrical fueling tank that holds the gasoline for its pumps, as modeled below. The tank holds a maximum of 20,000 gallons of gasoline and has a length of 34.5 feet. A metal pole is used to measure how much gas is in the tank. To the nearest tenth of a foot, how long does the pole need to be in order to reach the bottom of the tank and still extend 1 foot outside the tank? So in this question, I already labeled the diagram before before starting the video. So what we're really looking for here is the dimension that is the diameter of this tank. We need to know what is the diameter of this tank because the pole needs to go from the top of the cylinder down to the very bottom of the cylinder, and that is going to be the diameter. But we also need the pole to extend 1 foot out, right? So at the end there, the total height that we're looking for of the pole, which I'm going to label as h will equal to d plus 1. Whatever value that we end up with, okay, we will need to add 1 to it. Notice that they gave us a conversion factor that 1 cubic feet is equal to 7.48 gallons. So what I'm going to do is I'm going to convert the volume of the cylinder first from gallons into cubic feet because I'm given a dimension in feet. And at the end, I will also need to determine my values in the unit of feet anyway. Okay, so I'm going to convert the 20,000 gallons into feet, cubic feet. So 20,000 gallons into cubic feet. So I know that there are 7.48 gallons. So where am I going to place the 7.48 gallons? Is it going to be in a numerator or denominator? Because I want the gallons to cancel out, and the way that I have it situated right now, the gallons in the numerator. So the 7.48 gallons should definitely be in the denominator because I want the units of gallons to cancel. For every 7.48 gallons, there is 1 cubic feet. So I'm going to place the cubic feet in the numerator. So notice the gallons cancel. And now all I got to do is just take 20,000 divided by 7.48. So I'm going to go to my calculator. 20,000 divided by 7.48. And that is 2673.8 approximately. 2673.8. So this is 2673.8. Okay, cubic feet. So what I'm going to do with this now is, this is the volume of the tank in cubic feet. And it says that in the beginning of the problem here that the tank is, we're modeling the situation as a cylinder. So the volume of a cylinder is pi r squared times h. I don't know what the radius is. This is what I'm trying to find at the end, right? I do know what the height of the cylinder is. That is 34.5. So I'm going to take this information here. So 2673.8 will equal to pi times the radius squared times 34.5. I can now solve for r. I'm going to divide both sides by 34.5. So 2673.8 divided by 34.5 is equal to pi r squared. I'm going to divide both sides by pi, so I get 2673.8 over 34.5 pi is equal to r squared. I'm going to take the square root of both sides. Square root of 2673.8 over 34.5 pi. This is the value that I'm going to enter into the calculator, but I'm really looking for the value of d, right? So I'm going to double this. So I'm going to do 2 times the square root of 2673.8 over 34.5 pi. And the real value that I'm looking for is really h, and h is equal to d plus 1. So whatever value that I get for d, at the end I'm going to have to add 1 to it, right? So let's enter this into the calculator. So I'm going to go to my calculator. So I'm going to press 2, square root, 2673.967. That's still there in a calculator. So I'm going to press second, answer, right? If you don't have it already saved in your calculator, of course, you're going to have to retype that in. Divided by 34.5 pi. Notice I placed an open parentheses there because I want the answer to be divided by the product of 34.5 pi, close parentheses. This is going to be the diameter. It's 9.93 feet. So I will need to add 1 to this. That will be 10.93, right? So 9.93 is the diameter. So D is 9.93 feet. So H will be 10.93 feet. And they want our answer to be, let me see here, to the nearest tenth of a foot. So H is approximately 10.9 feet. And there you go.